Alright, let's talk about solving a quadratic when you don't have real solutions. This is really the motivation, one of the motivations behind the concept of complex numbers. When I try to solve this equation, notice it doesn't factor. So let's use the quadratic formula and let's just quickly solve this equation. The quadratic formula says negative b, here remember a, b, and c. You've got a is 1, b is 4, c is 1. So negative b plus or minus the square root of b squared, which is 16, minus 4ac, which is 1 and 1, all over 2a. It's a bad example because that's going to, I'll do this example, then do another one. This one is going to have two solutions, and the reason I know that is because right here, this is called the determinant, or the discriminant rather. The discriminant is positive. When the discriminant is positive, you know that there's two solutions. So when this should be 1 right here. So it's going to be negative 4 plus or minus the square root of 12 all over 2, which simplifies out to root 12 is 2 root 3, right? I can cancel a 2 from all of these, so I just get negative 2 plus or minus root 3. And there are my two answers. Negative 2 plus root 3 and negative 2 minus root 3. Those are my two x-intercepts. If I were to graph the equation y equals that, those would be my two x-intercepts. It would be, there's negative 2, it would be root 3 away from it on the right and root 3 away from it on the left, and the graph would be opening, your y-intercept would be 1, so your graph would look something like that.
Wait, why would you like add negative 2 and root 3?
Because negative 2 root 3, I can't, that's just a decimal. So this is the exact way of writing it. Okay? Now, what happens if I have an equation like 0 equals x squared plus 4x plus 6, let's say. Notice this again doesn't factor, so let's use the quadratic formula. When I find my solutions, negative b plus or minus the square root of b squared minus 4ac, notice what I'm going to get all over 2a. What am I going to get in the what's the determinant, the discriminant in this case? It's going to be a negative 10, right? So it's negative 4 plus or minus negative root 10 over 2. So they're going to ask you, if I look at this graph right here, the graph is going to have a y-intercept of 6, and it's going to open up like that, so it's never going to cross the x-axis. That's why I have no x-intercept, no real x-intercepts. That's why the two solutions here, see how there's 2 plus or minus, are imaginary. So they're going to want me to write it as a complex number. So let's do that. Negative 4 over 2 plus or minus I root 10 over 2. So let's write the two answers out. It's going to be negative 2 plus root 10 halves I, and negative 2 minus root 10 halves I. Those are my two complex solutions to this quadratic equation. There are no real solutions, there's too complex, and that's the motivation behind why you might want to use an I, and they've introduced I to you in this chapter.